How do temperature and volume affect pressure? Pressure is, by definition, the force exerted by a substance, in this case a gas, on the walls of its container. Gay-Lussac's law states that the pressure of a gas varies directly with temperature so long as the volume is held constant. This graph shows that as the temperature of an ideal gas increases, so does its pressure. This relationship can also be represented by this equation, which states that the starting pressure of a gas divided by the starting temperature is equivalent to the new pressure divided by the new temperature. But why? Why does the temperature affect the pressure of a gas? This question brings us back to the definition of pressure. Gas molecules are in constant motion. Pressure is the force exerted by these molecules on the walls of their container. So say we've got a gas in this little red airtight box. The pressure is increased when the gas molecules are hitting the walls of their container harder or more frequently. Now that we have sufficient background information, let's see what happens to the pressure of this gas when we take our little red box and heat it up. As the temperature increases, so does the kinetic energy of the gas molecules. This means that they are moving faster and therefore impacting the container walls more often. Thus, the pressure has been increased. This pattern continues as we increase the heat. So now we've answered the first part of our question. An increase in temperature causes an increase in the pressure of an ideal gas by increasing the kinetic energy and causing the molecules to impact the walls of their container more frequently. But what about volume? How does that factor in? The answer is Boyle's law, which states that if the temperature is constant, the volume of an ideal gas varies inversely, or indirectly, with the pressure of the gas. As the volume of the gas decreases, the pressure increases, as shown in this graph. Boyle's law is represented by this equation, which states that the starting pressure multiplied by the starting volume of an ideal gas is equivalent to the new pressure of this gas multiplied by its new volume. But why? Why does the volume of space that a gas takes up affect its pressure? Take a look at the gas trapped in this airtight pink box. As the box shrinks, the gas molecules have less space to move around in. They aren't gaining energy, so therefore are not moving any faster. But as the volume of space that they can move around in diminishes, they impact the walls of the box with more and more force. This shows a decrease in volume, causing an increase in pressure. In summary, Gay-Lussac's law defines the direct relationship between pressure and temperature, in which an increase in temperature causes the gas molecules to gain kinetic energy and impact the walls of their container more frequently, while Boyle's law defines the indirect relationship between pressure and volume, in which a decrease in volume gives the gas molecules less space to move around in and causes them to hit the walls of their container harder. In both of these scenarios, the result is an increase in pressure,